All right, the last thing we're going to look at in chapter 1 is going to be dealing with the absolute value some more. But now we're going to deal with absolute value in terms of an inequality. So step number 1, okay, we're going to solve it just like it's an equation. So again, when we solve absolute value equations, remember step number 1, get your absolute value alone, which we have. Okay. Number 2, we want to make 2 equations. One, when I take what's on the inside of my absolute value, x plus 4, let it equal what's on the outside, 6. And then the second case, taking the opposite of what's on the inside and setting it equal to the outside. So the opposite of x, the opposite of 4, and again, leaving it equal to 6. We want to keep that distance of 6. Again, absolute value tells us how far from 0, so we want to keep that 6 positive. Then we went in and solved. And so one of my solutions would be when x equals 2. Okay. In the other case, again, don't lose that negative because it's as if it's a negative 1 out there that we're multiplying by, so I got to divide by negative 1, so then I get x equals negative 10. So truly, if we are pretty good with solving equations, the first step here shouldn't be a problem. Now, what's going to be helpful for us is if we now put those values onto a number line. Okay, so I'm going to put my solutions on the number line. Negative 10, positive 2. Make sure you go in the right order numerically. Don't just put the 2 here because you found it first, and the negative 2 there, or negative 10 there because you found it second. That's not the correct order on the number line. Okay. So I'll put those solutions on my number line. What I'm going to look at is my original inequality sign. So look at your original inequality sign, because that's going to help me determine open or close. So since I have the equal sign here, that means I'm going to have a closed circle at each one of these. These 2 points will make those 2 sides balance. And what we should do is check that. We should check negative 10 plus 4, negative 6. Absolute value is positive 6. Okay, that works. 2 plus 4 is 6. That's what works there as well. Okay. Now, probably the easiest thing for us to do to be successful here is go in and check regions. So what I mean there is pick a point in each region. Okay. So I'm going to pick a point out here, say negative 12. I'm going to pick a point in here. I like 0. I'm going to pick a point in this region, 5. Okay. And what I'm going to do is plug it into the original to see if it's true or false. Okay, so I'm going to go and I'm going to start with my negative 12, and I'm going to plug it in for x. So negative 12 plus 4 is a negative 8. Absolute value of 8 is positive 8. That's greater than or equal to 6. So out here, it works. It's true. Okay. If I plug in 0, 0 plus 4 is 4. Absolute value of 4 is 4. 4 is not greater than 0. So it's false in here. So I go to the outside. I'm going to go out to that 5. Okay. 5 plus 4 is 9. Absolute value of 9 is 9. It's greater than 6. So out in this region, also true. So what we get is solutions out there, solutions out there. What this situation should look like is your compound inequalities. Okay, your ors or your ands. And one of the things that we're going to look at is we should be able to check these and make sure I come up with a compound inequality. If it doesn't look like a compound inequality, I probably did something wrong. Now, another thing that some people will talk about is once I find those values and we go back to our original statement, what I want is some distance that's more than 6 units away. Okay? And so since I want a distance that's more than, okay, what I want to get is farther away from these 2 numbers that I found, the 2 and the negative 10. Okay? So I don't like to say 0 because there are cases where both those values are positive, but I want distances that are getting bigger. Okay, so that's why I'm going out. So we kind of looked at this in that inequality section. I know it's an OR now because, again, ORs in general go to the outsides. Ands in general are the stuff in between. Okay, so I'm thinking it's an OR. And so what I want to do is write an inequality for each of these. So I want to write an inequality where I'm comparing x to negative 10. Because it's a closed circle, we have the equals. Inequalities point left, so I want the arrows point left, so I want my inequality pointing left. Compare my x with 2. Again, I need the equal. There's my solution. If I pick any number that's less than negative 10, less than or equal to negative 10, or if I pick a number that's greater than or equal to 2 and plug it back into my original inequality, it's going to work. Okay. All right, so absolute value of 2x minus 7 less than 1. Okay. So if we go through our stages again, number 1, solve it like it's an equation. So inside equals outside. Okay. Opposite of 2x, opposite of negative 7. Okay. And again, we always want to keep this distance the same. So I'll solve each of those. And so one of my critical points, okay, one of my points where we change is at 4. My other critical value, again, don't lose that negative, is at 3. All right, so again, now put those points on the number line. So I have 3 and I have 4. So again, 3 comes before 4. Okay. And again, like I said, this is why I can't say I need things farther from 0, okay, or closer to 0, because both of them are positive. Okay. Looking at my original inequality, less than, so it's going to be open. Checking points. I'm always going to check 0. Yep, sometimes we have to check decimals or fractions, okay, but we're able to do that. If we have to use our calculator, we will. So if I plug in 0 again, like I said, the great thing about 0 is that that chunk goes to 0, so I'm left with negative 7. Absolute value of that is positive 7, not less than 1. Okay. I'm going to go with the 5 next, just because it's a integer. So 2 times 5 is 10. 10 minus 7 is 3. Absolute value of 3 is 3. 3 is not less than 1, so it didn't work out there either. Now, 3.5. If I take 2 times 3.5, I get 7. 7 minus 7 is 0. Absolute value of 0 is 0. That is less than 1. My solution set's in between here. Okay. So again, like I said, I recognize that as a compound inequality. So that's an and. Okay. So when I write this inequality, I'm going to look at one of them is going that way because we have to overlap. The other one is coming this way. Okay, so one's going to the right, one's going to the left. We overlap. That's how we're getting our middle. So if I'm writing this inequality, I'm comparing x with 3. No equal sign because it's open. Arrows left, right, I'm sorry. Inequality's right. Okay. This other one I'm comparing x to 4. No equals. Points left. Like I said, I'm okay with this notation, having it listed as 2 separate. As you get better with these, you're going to recognize, hey, all I really need to do to show it algebraically is put the variable in between the two. But again, make sure when you do that, your inequalities are pointing the same direction. All right, now last situation I want to talk about is if I do have a case like this, where I have 2 times the absolute value of x plus 7 minus 3 greater than or equal to 9. Okay, I still need to get the absolute value alone first. Okay, So what I'll do again is it's just like 2 times something minus 3. So we go with the plus 3. And then we divide that 2 away. Okay. Now, what I'm going to ask you to do is to pause the video, go through and solve this on your own, and then when you restart it, I'll have it all finished, and you can see how you did. All right, so here's where we should have gotten. Okay, we were at that point where you had the absolute value of x plus 7 greater than or equal to 6. So again, I broke it up 2 parts. Okay, there's my in equals out. Opposite of x, opposite of 7 equals the out. Solved it, got x equals -1, got x equals -3. Again, don't lose that negative sign. Okay. Put those points on the number line. Again, remember, right order, -13 comes before -1. Went back to my original, saw that there was an equal sign, so I closed them in, made a solid dot, and started testing points. Now, when I test my points, make sure you're going back to the original. So in this case, if I started with the -15 on the left side, okay, -15, working inside, plus 7 gives me a -8. Absolute value is a +8. We have to simplify what's inside the grouping symbol first. 2 times 8 is 16. 16 minus 3 is 13, which is greater than or equal to 9. So -15 worked. Okay. So that's why I gave ourselves a true sign out here. Okay. Be careful with the negatives. If I go to the -2, -2 plus 7 gives you a 5. Absolute value of 5 is 5 times 2 is 10 minus 3 is 7. Doesn't work. Okay. That's why we got false here. Okay. If I plug in 0, okay, again, nice thing is I get 7. Absolute value is 7 times 2 is 14 minus 3, okay, is 11, which is greater than 6. Okay, so that's where we get this other true. So again, outsides indicates or. Okay. Write your inequality for that one. X compared to -13, equal sign, pointing left. Write your inequality for this chunk. X compared to -1, equal sign, points to the right.